Hi guys, welcome back to this channel where I regularly update and post videos. So today we're going to look at competitive programming. So what is competitive programming? It's basically trying to use algorithms to solve math questions. And you can find all these questions in many websites such as Top Chef or LeetCode. And I actually prefer LeetCode the most because the user interface is the nicest. So yeah, let's just go into a contest to see how it is done. So in a typical contest on LeetCode, you will have 4 questions. The first question will be easy, and then the next 2 questions will be medium difficulty, and the last one will be hard. And well, actually, even the easy question can be pretty difficult. So yeah, the tag is not really very accurate. Anyways, let's jump right into it. So for the first question, it is to check if a string is prefix of an array. Okay, so I'll zoom in so y'all can see. Yeah, so you're given a string S and you have an array of string words. Then you just want to check if the string is a prefix of the words. So let's say your string is I love LeetCode. Then your words are I love LeetCode apples. Then you see your string can be formed by concatenating the rest of the words together. So yeah, this is possible. And if your string is I love LeetCode but the words are apple, I love LeetCode, then it is impossible to form as a prefix of this because it starts with apples. So yeah, you just gotta return true if it is a prefix string and false if it is not. So yep, then we can start coding. So okay, so we're just gonna check if it is a prefix of the words. So we'll let string t equals to this empty string first, then we will look through the words array. Dot size. Okay, then we will slowly add each word into the t, and then we check if t dot size is greater or equals to s dot size, which is our string that we want. Then we will just break. And if t equals to s, then it's true, we just return true. By the end of it, if it is not true, then we will simply return false. And then once we are done with that, we can scroll down and click run code to test on the sample cases. And expected answer true, your answer false, so something is wrong. So what is wrong over here? When we add in this is the string t, words dot size it, add the words. If t dot size is greater, then that's okay. It shouldn't have broken here, it should have continued. Okay, run code again, and yeah, true. Alright, then we submit our answer and it says accepted, so we can move on to the next question. Yeah, by the way, if you are thinking about how long it takes to solve these kind of questions, well, we can just look at the ranking. So well, I've actually done this contest before. So I finished the first question in 3 minutes, the next question by 7 minutes, and the question by 32 minutes. But as you can see, some people finished all the questions in the first 5 minutes, and yeah, they finished the first question that we saw just now in 33 seconds. So well, guess they're just a bit different. Anyways, let's go back to our contest. Let's not get distracted. Okay, let's go to the next question. Remove stones to minimize the total. Okay, once again, let me zoom in so you can read the question. You're given piles, and each pile represents a number of stones, and you can choose any pile and remove piles divided by 2 stones from it. Then you will want to return the minimum number of stones after doing this k times. So obviously, you will always want to reduce the greatest pile. So yeah, so in this case, let's say you have 5, 4 and 9, you have 3 piles of these stones, and then you can only perform this operation twice. So obviously you want to perform the operations on the biggest numbers to reduce it the most. So you apply the operation on on 9, then you become 5. It's basically divided by 2, you see. And then if you apply the operation on 5, you become 3. And then we just return the remaining number of stones. Yeah, pretty straightforward. So the quite obvious strategy over here will be to just try to constantly reduce from the greatest pile. So how do we keep track of the greatest pile? Well, there's this thing called priority queue. So what it does is that it always puts the greatest element at the top of the queue, and we can make use of that. Okay, so first of all, we're going to declare a priority queue. Oh wait, this is not how we define it. Oops. Okay, then pulse dot size. We're just going to push all these piles of stones into the priority queue. Alright. Okay, next nesting k, because we're going to perform this operation k times. So each operation, what we're going to do is we're going to take the stones as the top from the priority queue. Then after that, we are going to pop it out of the priority queue, and then we will remove half of it. So floor stones number 2. Then we will just insert back into the priority queue. So after it has done k operations, then we are basically done, and then we just have to count the remaining stones. So how do we count the remaining stones? All we have to do is initialize a total variable. Then after that, we will go while pq.empty, and we will say total plus equals to pq.top, and then we will pop it. So by the end of this, we just need to return total and be correct. Once again, run code to test. 12, 12, nice, and then we submit it. Okay, it's accepted. Alright, now on to the third question, which should be slightly more challenging. Now the difficulty is medium. Alright, so minimum number of swaps to make the string balanced. I'm given a 0 index string S of even length, so half of it has opening brackets and the other half of it has closing brackets. A string is balanced if and only if it is empty. It can be written as AB, where AB are balanced strings, or it can be written as C, where C is a balanced string. So what this means is that let's say I have something like this. This is a balanced string. So basically every open bracket must be accompanied by a closing bracket. This is okay, or I can also do this. So I have brackets inside of it and a bracket outside of it. These two are connected and these two are connected. This is also okay. So what sort of sequence is it does it make it imbalanced? Well, if we do it like this, closing bracket before the opening bracket, then it will be imbalanced. Then in this case, when it is imbalanced, we will need to perform a swap. So the whole point is to count the minimum number of swaps. So when we swap it, it will become like this. So this is one swap, and then it will become correct. But this is wrong. Alright, so what we do is we will go through the entire sequence of the string, and then for those that are correct, we will simply remove it first. So for example, our string is something like this. Okay, and then we will pass it into our stack. Then when we see there's this self-closing bracket which is correct, we will simply just remove it. Then we'll be left with 1, 2, 3, 4. And then once we have 4 of this left, all we need to do is just perform a swap. So we will swap this and this. So this will now become like this, and this will become like this. So now it closes itself and it closes here also. So for this, we just need to perform one swap. So let's implement this now. Okay, so first of all, we will need a stack. So we'll stack. Okay, and then we will initialize a counter. And then we will loop through the string. So this is the current character that we're looking at. And if the stack is empty, then what we're gonna do is push it into the stack. And well, if it is not empty, then we're going to have to check different cases. So if stack.top is equal to opening bracket and our current value is equal to a closing bracket, then all we have to do is just pop the current stack. So just pop it, or else we will just push in our current value as well. Push, okay, current value. Okay, and once it's done, by the end of this, all the ones that are remaining inside the stack are those that are not correct. So there'll be like the 4 that remain just now. So all we have to do is count the number of brackets still remaining in the stack. So how do we do this? While stack.empty, we're gonna pop it, and then after this we'll increase our counter by 1. And yeah, so this will count the number of elements that are still remaining in the stack. And then once we have this counter, all we need to do is to divide by 4. Return 0, rounded up of course. Alright. And you run our code. And 1 it is correct, and we submit it, and it's accepted. Nice. Right, so back to the contest for the last question. It's pretty difficult. Difficulty is hard, and until now I still haven't solved it yet, but y'all can have a look first. So basically, you are given a 0 index integer array obstacles of length n. Obstacles I is the height of the ith obstacle. And so at every index, you can choose a number of obstacles. And you must include the ith obstacle. You must put the chosen obstacles in the same order as they appear. And every obstacle must be taller or the same as the obstacle immediately before it. Well, it sounds pretty confusing, right? Yeah, it is really that confusing. So we have an example over here. Let's say obstacles is 1, 2, 3, 2. Now how would this look like? Okay, let me draw it out. Wait, where is the eraser? Pencil. Nope. How is there no eraser? Hold on. Technical difficulty. No, definitely not shapes. What? Can't believe it. Oh, it's under pencil. Wow. That's pretty smart. Alright. Erase. Okay, so now we switch back to our pencil. And okay, so look at our input. 1, 2, 3, 2. What this means is that the first obstacle has height 1, second obstacle has height 2, third obstacle has height 3, and the last obstacle has height 2. So at the first index, which is over here, what is the greatest length of obstacles you can form? You can only form 1 because you're just here, you only have 1 to form. And the second one, you can form an obstacle like this, so it will be 2. Third one, you can form an obstacle that is length 3, so it will be 3. Fourth one, because it is only height 2, so I can only take 1, 2, and 2. So the maximum length of this obstacle will be 3. So answer will return 1, 2, 3, 3. I'll put 1, 2, 3, 3 over here. Well, if you still don't get it, it's fine because I don't really get it either. And yeah, so what do we do about this question now? Well, strategy here is actually quite simple. So in computer science, everything is about optimization and being efficient. So right now, the most efficient thing to do would be to simply close this tab and move on with our lives. So yeah, see y'all next week. Well, actually probably not next week though, but see y'all sometime soon. Bye bye. Okay, how do I stop the recording? Player. Oh, okay.